Hello everyone, and welcome to today's presentation on finding square roots with precision using the binary search approach. A square root of a number, let's understand the problem statement. So we would like to find out a square root of any number. So for example, 50 is given, so we would like to find out up to 5 decimal points. So then how can we do it without using any inbuilt functionality? So yeah, that's what we would be focusing in this one. So the approach what we are considering is binary search approach. So as we know, binary search is an efficient algorithm and fundamental approach that can be used to efficiently locate an element in a sorted array by repeatedly dividing the search interval in half. So the basic approach is, so we start by setting the lower and upper bounds of our search range. Okay, so for the number greater than or equal to 1, so the upper bound is the number itself. For numbers less than 1, we set the upper bound to 1. So in each iteration, we calculate the midpoint and check if its square is greater than or less than the target number and adjust our search range accordingly. So this process continues until the difference between the search interval, that is a high and low bounds, is smaller than the desired precision. So ensuring the accurate result. So the advantage of this approach is basically it is highly efficient. That is reducing the number of iterations needed to reach the desired precision compared to linear search method. Okay, so here let's see its implementation. So let's look at the function which calculates the square root of a given number up to a specified number of decimal places using binary search method. So first is in this first condition is basically the if number is less than 0, return none. So this block of the code handles negative numbers. If there is a negative number, it doesn't give anything, it returns none. So similarly, setting the initial search range, that is a low to high. If the number is more than 1, the number itself is the high range. Otherwise, if it is less than 1, it is 1. Okay, mid is initialized with 0. And the entire logic is found over here. That is, if the precision, that is high minus low, the search range is greater than this 10 power precision. So we are going to find the midpoint and then we are going to check that number. If that square is equals to the number, then the greater than the number, then of course, so we have to reduce the search range towards a smaller end. So that's why high should be mid. Otherwise, low should be mid. Okay, so then we round it up to that precision. Okay, so until we have to repeat this one until we find out the mid square is equal to number up to that particular precision level. So overall time complexity is O of precision because the number of iterations depends upon the precision, number of decimal places, right? Similarly, the space complexity is O of 1 because since only a fixed amount of extra memory is required, regardless of the input size or precision. So the binary search is efficient with linear time complexity related to precision. So memory usage is minimal, making the algorithm is highly space efficient. Thank you.